Hello again and welcome guys to another G Squared Academy video. We are doing our examination preparations right now. We're not going to delay. Just thank you guys for all the subscribes, shares, likes, everything that you have been doing. I hope the videos have been helping you and that they will make you or help to make you successful in your exam. Today, what we're going to be looking at is volumetric analysis, titration calculations. This can be a very sore point for students. So we want to go through a couple of those things. So without further ado, let us get right into it. Okay, so here we have a question, might be a little bit obscure, but try to get it as big as I could so that you guys can see that clearly. Okay, so here we go. 20 centimeters cube of 0.05 molar. And notice I said molar instead of moles per dm cube because we tend to say molar for the moles concentration. So moles per dm cube, same thing. Sulfuric acid neutralized 25 centimeters cube. And you might hear me say mils from time to time, interchangeably with centimeters cube. They're the same size. Of sodium hydroxide solution. What is the concentration in moles of the sodium hydroxide solution? Now, generally speaking, you will be given information about one thing generally, and then you're supposed to find the concentration of the other species. You may be given both, and then you're supposed to find the mole ratio. But generally speaking, you would be given the information for one of those species. So you have to now look at what you have. Okay, these questions don't come with a lot of decorations. By decorations, I mean things that you don't really need, but the examiner just put it on the paper to distract you. So I call those things decorations. All right, so let's see what we have here now. First of all, 20 centimeters cube of 0.05 molar sulfuric acid. So we know the volume of the sulfuric acid and we know its concentration. Okay. They also gave us that it reacted with sodium hydroxide, 25 centimeters cube of sodium hydroxide. So what's the first thing you want to do? First thing you want to do is calculate the moles of the standard, the solution of known concentration in the volume of the standard. So what you need to know, remember, is that this molarity here, 0.5 moles per dm cube, actually means 0.05 moles in 1,000 centimeters cube. Okay, so if I have that number and I want to find the number of moles in 20 centimeters cube, then all I would need to now do is simply say that x moles is equal to 20 centimeters cube. And then I'm going to cross multiply. X is going to be equal to 20 centimeters cube times 0.05 moles divided by 1,000 centimeters cube. Centimeters cube cancel, and so your x is going to be equal to 1 times 10 to the minus 3 moles. Okay, so what does this number of moles represent? You have to look at what you just calculated. We just found the number of moles of sulfuric acid in 20 centimeters cube. Okay, and that is 1.0 times 10 to the minus 3 moles. So now you know the moles of sulfuric acid that is reacting in this experiment, or how much has reacted. The next question, generally speaking, is for you to find out the amount of sodium hydroxide it reacted with. So you know 1 times 10 to the minus 3 moles of sulfuric acid reacted. How many moles of sodium hydroxide did that react with? For you to do that, you now need to go and write the equation. So the equation is sodium hydroxide, and I might just ignore state symbols here just for simplicity. Excuse me. So sodium hydroxide plus sulfuric acid produces sodium sulfate, Na2SO4, plus water. Of course, this is an acid-base reaction, H2O. So now what we need to do now is to balance this equation. You have 2 sodiums on the right and 1 on the left. So let's just put a 2 there and put a 2 in front of water. There you go. Okay, so now we know based on this balance equation that 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. 1 mole of sulfuric acid. Now, just remember now that we actually just calculated the moles of sulfuric acid that was actually reacting in this experiment. And we found that it was 1 times 10 to the minus 3 moles. So if theoretically, and that theoretically we get those values from the equation, 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. And in practice, I have 1 times 10 to the minus 3 moles of sulfuric acid. How much sodium hydroxide will that react with? So that would be X. And so your X would work out to be 2 times 1 times 10 to the minus 3, which basically is equal to 2 times 10 to the minus 3 moles. Okay, so this now would represent the moles of sodium hydroxide that reacted in the volume of sodium hydroxide that reacted. Okay, so let us just clear all of that. Now, so let us go back. So we found that in this 20 centimeters cube of sodium sulfuric acid, you have 1 times 10 to the minus 3 moles of sulfuric acid. That reacted with 25 centimeters cube of sodium hydroxide, and it turned out to be 2 times 10 to the minus 3 moles of sodium hydroxide that was present in that. The next thing that you want to do now is you want to now find out the number of moles of sodium hydroxide in 1,000 centimeters cube. Why 1,000 centimeters cube? Because concentration is measured per 1,000 centimeter cube. Okay, so you would see us have, as you see here, moles per dm cube. 1 dm cube is the same thing as 1,000 centimeters cube. It's the same thing as 1 liter, and it's the same thing as 1,000 milliliters. Okay, so concentration, excuse me, concentration is per 1,000 centimeters cube, or per liter, or per dm cube. All right, so what do we now do? So we now know the moles of sodium hydroxide. So we now say to ourselves, right, 2 times 10 to the minus 3 moles of sodium hydroxide is equal to 25 centimeters cube. Okay, so how much would be in 1,000 centimeters cube? Now, and that's going to be X. So then we cross multiply, right? We cross multiply, and X is going to be equal to 2 times 10 to the minus 3 moles times 1,000 centimeters cube divided by 25 centimeters cube. Centimeters cube cancel, leaving moles. So X would now going to be equal to 0.08 moles. All right, so now that's the number of moles. Now, in what quantity of solution is this present? 1,000 centimeters cube. So this 0.08 moles of sodium hydroxide is present in 1,000 centimeters cube. Therefore, what we have found there is the molarity. We have found the number of moles in 1,000, which is the molarity, which is the moles per dm cube, the mole concentration. Okay, which would mean that we would have answered, let me clear all drawings so you can see what's happening here. So it means that we would have found the concentration in moles, because we found the number of moles in 1,000 centimeters cube for that question. Okay, and that's the end of that story. So let us move on to the next question. Let's clear all drawings here. And there's question 2. It says here that 25 centimeters cube of 0.1 molar moles per dm cube sodium hydroxide solution required 30 centimeters cube of sulfuric acid for neutralization. Calculate the concentration of sulfuric acid in moles per dm cube and grams per dm cube. So here they're asking you to find the molarity and the mass concentration. So remember I said earlier that concentration is the quantity of substance in 1,000 centimeters cube. You can quantify the substance in terms of moles. In that case, you'll get molarity, or you can quantify it in terms of mass. In that case, you get the mass concentration. Okay, so in this question, they're asking us to find the molarity and the mass concentration. Just coming down a bit so we can see it a little clearer. All right, so let us work this question. Again, first thing you want to do is to find the moles of sodium hydroxide in 25 centimeters cube. You always start with what you know first. Okay, so what do we do for that? For that, we're going to say that we have 0.1 moles in 1,000 centimeters cubed. Therefore, we have X moles in 25 centimeters cubed. So now what we're going to do now, make X the subject of a formula, and we're going to cross multiply. Okay, and so X now is going to be equal to 25 centimeters cubed times 0.1 moles divided by 1,000 centimeters cubed. And so X in that case would be equal to, so 2.5 times 10 to the minus 3 moles. And of course, this is the moles of sodium hydroxide. Remember, this is question 2 that we're looking at. All right, so that's the moles of sodium hydroxide in 25 mils. Let me clear it. So that's the moles of sodium hydroxide in 25 mils. So the next thing now is that we now need to find the moles of sulfuric acid that 2.5 times 10 to the minus 3 moles of sodium hydroxide reacted with. So what you're seeing here is that 25 mils of sodium hydroxide reacted with 30 mils of sulfuric acid. What we have done is we have found the number of moles of sodium hydroxide in the 25 mils, and now we're going to find the number of moles that it reacted with, the moles of sulfuric acid that it reacted with in the 30 centimeters cube of sulfuric acid. So again, you would have to write the equation. We just did this, so you'd remember that the equation is OH, and I'll just write OH for sodium hydroxide. OH to acid, which is the sulfuric acid, is 2 to 1. So 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. So if I actually have 2.5 times 10 to the minus 3 moles of sodium hydroxide, it's going to react with X moles of acid. Again, you cross multiply, and X is going to be equal to 2.5 times 10 to the minus 3 divided by 2. And that works out to be 1.25 times 10 to the minus 3, right? 1.25 times 10 to the minus 3, okay? And that now would be the moles of sulfuric acid that is present in the 30 mils of solution, okay? So that's the moles of sodium sulfuric acid present in 30 mils of solution. So the question now is, what is the moles in 1,000 centimeters cubed? See, this is actually exactly what it says, moles per 1,000 centimeters cubed. So let us find that now. So let me clear all drawings here. And so what we're going to know, right, is that if 1.25 times 10 to the minus 3 is in 30 centimeters cubed, and this is for sodium hydroxide, then X is in 1,000. And so now centimeters cubed. And so now you're going to say that X is equal to 1.25 times 10 to the minus 3 times 1,000 centimeters cubed, and this is moles, divided by, what was that now? 30 centimeters cubed. Centimeters cubed cancel. X works out to be 0.0417 moles per dm cube. And of course, this, because you would have found this number of moles in 1,000, it's moles per dm cube or moles per liter. All right, so that's the molarity now of the sulfuric acid, 0.0417. All right, so now the next step would be to find the grams per dm cube. Okay, so how do we do that now? There's a nice little equation which says that mass concentration is equal to molarity times molar mass. Okay, so we're trying to find mass concentration, which is the grams per liter. So what was the molarity? 0.0417 moles over dm cube, right? Times the molar mass of sulfuric acid, which is 98 grams over mole. So moles would cancel, right? Leaving grams per dm cube. And so that works out to be 4.08 grams per liter, 4.08 grams per dm cube. You might hear me say liters or dm cubes interchangeably. That's because they're the same value of substance. So therefore, that is our mass concentration of sulfuric acid. All right, I hope you guys are getting this. We're going to push on to another question. So question 3 on the paper, and I'm just going to scroll down so we can see this a little bit better. Question 3. It says here 50 centimeters cube of hydrochloric acid were needed. 50 centimeters cube were needed to neutralize 25 centimeters cube of 0.1 moles per dm cube potassium hydroxide. What is the concentration of the acid solution in moles? So they're asking you for the molarity here. Again, without further ado, let us dive right in. So you will notice that the standard solution in this case, the solution of known concentration, is potassium hydroxide. See it right there, 25 centimeters cube of 0.1 moles per dm cube. So you know the concentration of that solution. So now we just simply need to find the number of moles in 25 mils. So we can say 0.1, okay, 0.1. Do this in red again, not yellow. 0.1 is equal to 1,000 centimeters cube, right? Therefore, X is equal to 25 centimeters cube. Okay, and let me just bring this down a little bit so we can see the question. Right, there you go. So X is equal to 25 centimeters cube. So this is, so X would be equal to 25 times 0.1, 25 times 0.1 divided by 1,000 centimeters cube. And so X would be equal to 2.5 times 10 to the minus 3 moles. Okay, so that now would be the moles of potassium hydroxide. All right, that is present in 25 mils of potassium hydroxide. So the next step, as you know, is to write the equation and then find the moles of the acid in the volume of the acid. So let us clear all drawings here. So what we're going to write now is OH to represent the potassium hydroxide, 2H plus. Okay, and how many moles of OH did we have? 2.5 times 10 to the minus 3 to X. What's the mole ratio here? It's a 1-to-1 ratio. Okay, 1-to-1 ratio. And so therefore, if 2.5 times 10 to the minus 3 moles of OH is reacting, then it's going to be 2.5 times 10 to the minus 3 moles of acid. Okay. All right. So that's the moles of the acid that would be reacting. And this moles of acid is present in 50 mils of sodium hydrochloric acid. Therefore, we can now find the moles of hydrochloric acid in 1,000 centimeters cube. So let us do that now. So all we need to now do is say that 2.5 times 10 to the minus 3 is equal to 50 centimeters cube, and this is moles. Therefore, X is equal to 1,000 moles, 1,000 centimeters cube. Sorry. So X would be equal to 2.5 times 10 to the minus 3 moles times 1,000 centimeters cube divided by 50 centimeters cube. Centimeters cube cancel. And so X is equal to 0.05 moles. And of course, since this is in 1,000 centimeters cube, we can say moles per dm cube. All right, so that now would be the concentration of our hydrochloric acid. And generally speaking, this is how the questions are asked for you to do the calculations. So just to point out, though, that you may be given a situation where you have to find the volume of the reacting species based on a thermometric titration. And thermometric titrations usually deal with acid-base reaction. Now, in an acid-base reaction, what you're going to have happening is that the temperature is going to rise and then it's going to fall. Okay, so for you to find the volume, and over here you have your temperature, and then you have your volume down here. So, and this is in centimeters cube, of course, and this is in degrees Celsius. So what you have to simply do now, this point here is the end point of the reaction. So they may ask you to find the temperature. You can just go across like that, not drawn properly. And then you can go down here to find the volume to use in the calculation. So they will give you the molarity of the standard, but you'd have to find the volume of the standard from this graph after you have plotted it. And so this is how you then find the volume, and then you could use it just as how we have been using it. Okay, I hope you guys find this video helpful. Please like, share, subscribe to the channel. Please share the videos so that it can help people, you know, in preparation for their exam. Thank you guys, and I wish you all the best in your exams. See you next time.